Hello class and welcome to Math Minutes video lesson number 37. We're going to start looking at rules of exponents. This might seem a little confusing at first, lots of little details, but not too complicated. Just stick with me on it. Turn to your notebooks to page 17. I meant page 19, and we're going to get started learning some rules about exponents. Exponents are a shorthand way to show how many times a number, called the base, is multiplied times itself. A number with an exponent is said to be raised to the power of that exponent. So if you look at 4 with this little 3 up here, this is the base, this is the exponent. This is 4 to the third power, which means 4 is being multiplied to itself 3 times. 4 times 4 is 16. 16 times 4 is 64. This one here is 2 to the 5th power. That means 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5 equals 32 because 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So let's just practice writing. Our base is going to be whatever number is repeated. Our base number in this case is 2, raised to the power of what? Let's just count how many times it's being multiplied by itself. 1, 2, 3, 4, 5, 6. This is 2 to the 6th power. Our base is 6. This is being raised 1, 2, 3, 4 to the 4th power. Our next one, our base number is 4, and it's being raised 1, 2, 3, 4, 5 to the 5th power. A to the 6th. Now here's the other way. What's our base? Well, our base is always going to be what's being raised. So this is our A is our base. And it's being times by itself how many times? 6. That means A times A times A times A times A times A. 1, 2, 3, 4, 5, 6. What's our base in this one? W. How many W's? 4. W times W times W times W. So that is simply some notation and how things are written and what these exponents mean. So now let's take a look at what we're going to do with these exponents when we're multiplying them. The first and most important rule to remember when multiplying terms with exponents is the bases must be the same. For example, 4 to the 3rd power times 4 to the 7th, yes, can be multiplied, but 5 to the 3rd power times 2 to the 3rd power cannot be multiplied. Now the exponents are the same, but the bases are not. So the bases must be the same. After determining that the terms have the same base, then you can apply the rule of multiplying exponents. When multiplying two terms with identical bases, you add the exponents. For example, 6 to the 3rd power times 6 to the 5th. I can multiply these because my bases are the same. My base will stay the same here. I don't make it 6 times 6 is 36. My base will stay the same. All I have to do is add 3 plus 5, and that gives me 8. So let's take a look at some practice together. Yes, can I multiply these? Yes, my bases are the same, so that stays the same. What is 3 plus 7? This, 8 to the 3rd times 8 to the 7th will equal 8 to the 10th. How about this one? Yes, 15s. How many? What is 4 plus 9? We're multiplying, so we're adding the exponents. 4 plus 9 is 13. This is 15 to the 13th power. Really big number, by the way. Okay, let's take a look at this one. No, I cannot do this because my bases are different. No. Bad. Frown. Oh, can't do it. Okay, how about this one? Yes, because my bases, even though they're variables, they're the same variable. So that means y is going to be my base. 5 plus 12 is 17. There you have it. Let's move on to the next page. Page 21. When an exponent also has another exponent, there is a slightly different rule. So a term that looks like this, here's what I mean. An exponent has another exponent. This rule means that you will not add the exponents, but you will multiply the exponents. So in this example, the answer would be 4 to the 6th. Why? Because the exponents of 2, here's my 2, and my 3 are multiplied to get 6. Again, the 4 stays the same. So let's take a look at these few practice together. 6 is going to stay the same. But because I have an exponent on an exponent, it means I'm going to multiply 3 times 5, and that's going to give me 6 to the 15th. Number 2, my base will stay the same, but I'm going to multiply. 7 times 4 is 28. These are really big numbers. Okay, 10 to the 4th, my base stays the same, but again, exponent outside of another exponent, 4 times 3, 10 to the 12th. 8 is my base, that stays right there. 8, 4 times 6 is 24. Okay, so when we are exponent on exponent like that, we multiply. Let's take a look at how we divide exponents. Dividing terms with exponents has the same requirements as multiplying, which is the bases must be the same. When dividing two terms with identical bases, we are going to subtract the exponents. For example, bases are the same, I can subtract them. 8 minus 2 will give me 6, so this is 9 to the 6th power. So let's practice on this one. My bases are the same, yes, so I'm just going to write my base. 19 minus 9 is 10, so this is going to be 6 to the 10th. Our next one, bases are the same, yes, gives me an x. What is 7 minus 3 is 4, so this would equal x to the 4th. Our next page, this is a little reference chart. This is a little bit of a long lesson because there's just a lot of little bitty rules. So I really want you to take good notes on this, and you'll be able to refer to this while you're doing your homework, this page especially. So page 22, the reference chart. Let's take a look at it. If a problem looks like this, if I have two of the same bases and I'm multiplying, I'm going to add the exponents, and that would give me a to the 7th. When I have an exponent outside of another exponent in parentheses, I will multiply and get 5 times 2 is 10. When I am dividing and I have the same bases, I'm going to subtract, and 5 minus 2 is 3. So please refer to that when you're trying to do your work. Let's take a minute to understand why these rules work, and it might help you to remember them. A to the 5th, remember what a to the 5th was? It was a times a times a times a times a. 1, 2, 3, 4, 5. Well, now I'm timesing all of that times a squared, another 2 of them. A times a. So I have like my first one, a to the 5th. I have my second one, a squared. Well, how many total? How many a's am I multiplying? 1, 2, 3, 4, 5, 6, 7. This is why we add when we're multiplying. Let's take a look at what this one means. what are we really squaring here? To the second power means squared. Well, I am squaring a to the fifth. So what does that mean? Well, what's a to the fifth? Again, it's this. It's a times a times a times a. 1, 2, 3, 4 times a. But now I've got the squared. That means all of this is being multiplied again. So this becomes the base. It's this base times itself again, which would mean a times a times a. Oh my goodness, running out of space. 1, 2, 3, 4, 5. Well, now how many a's do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, 5 times 2 is 10. This is why this a to the fifth is the base of what's being squared. All right? Let's take a look at the next one. Well, this time I have a to the fifth, so let's do that again. A times a times a. 1, 2, 3, 4, 5. And it's being divided. Let's do it this way. Remember, a fraction is like division. What's it being divided by? A squared, which means two of them. A times a. Well, you know when we're doing, when we have a fraction and, or say we're going to say 2y divided by 2. And remember how we just cancel those out because it's the same number on top as the same number on the bottom? That's what's going on here. Well, this a can cancel that a. This a, or any of them, is going to cancel out that one. How many are left? 1, 2, 3. That's why 5 minus 2 is 3. That's why when you are dividing, you are going to subtract the exponents. So again, I hope this helps as well to understand that it's not just random rules, but let's just kind of see why it works. And so again, you can refer to page 22 when you're working on your assignment. Okay, page 23, we're going to practice applying some of these rules. Those first couple pages of this lesson, we're explaining the rules. Now let's practice some together. So let's look at what I have here. Oh, and this is kind of expanding it. So this time I'm going to multiply my 8 and my 2 because the 8 isn't, these aren't bases. 8 is not being raised to the power of 4. Only the a is. So I'm going to take 8 times 2. I'm going to kind of do that. 8 times 2 is 16. Then I'm going to apply my rule here. A to the fourth is being multiplied by a squared. They both have the same base, so I'm going to keep that base. And then when I am multiplying, I add my exponents, so 4 plus 2 is 6. So my answer is 16a to the sixth. Let's look at the next one. Well, now I do have to pay attention to my bases. Are these the same? I have x cubed y times x to the fourth y squared. Anything raised to the third power can also be called cubed. So sometimes I'll say x to the third, or I will say x cubed. I will always say y squared. So I'm going to multiply my x's together. So when I am multiplying my x's, I'm going to add my exponents. So x to the third times x to the fourth means x to the seventh because 3 plus 4 is 7. And then what are my y's doing? I'm multiplying my y's. This y doesn't have an exponent, but you know what we can like, if this helps you to visualize or remember, there's really a 1 there. It's just y by itself. There's one of them. So now I'm going to take 1 plus 2 gives me y to the third. A common error that I'm pointing out so that you don't make it is to just see the 2 and think that it's squared. But it's not. There's 2 y's here, but there's another one here, 2 of them here, plus that 1. This has to be to the third power or cubed. Okay, now what's happening with something like this? Well, this number on the outside gets distributed, or we have to apply it to each variable. Okay, so what that means is it's going to become x cubed, y cubed, and that's just one term. This cubed has to go to this term, that variable, and that variable. Let's take a look at this one. Oh my gosh, it looks huge and complicated, but let's just break it down to the steps that we know. The 4 doesn't have an exponent on it, and neither does the 3. Oh, here we go. We are adding. I was thinking that was a different sign. We are adding. What's the rule for adding with variables? The exponents or the variables have to be identical. I cannot take 2x and add it to 3a because the x and the a are different. So when I'm working with numbers and variables with exponents, I have to look at what's the little tag here? X squared y squared is the same as x squared y squared. Yes, that means I'm simply going to take the 4 and the 3, add them together, gives me 7, and then I'm just going to tag my ending on x squared y squared. This is like what hopefully you remember. If I have a 2x and I want to add a 3x, it becomes 5x. That's what we did. Let me erase that so you can see the equation again. We took the 4, we added the 3, and we just kept its little last name, just like we kept the x's over there. Okay? We have more. Page 24. Now, if you look at these two, we have -3 cubed and -3 cubed. But what is the difference? This -3 doesn't have parentheses around it. This -3 does. It will make a difference in your answer. I think in this case they end up the same, but I'll do another one to show you where they don't. This means the only thing being cubed is the 3, not the negative. This means -3 times 3 times 3. And it's treated, that little negative sign doesn't count. We do this first. 3 times 3 is 9. 9 times 3 is 27. So that accounts for 3 cubed, and then we just make it negative. This one here means, so you see how the 3 cubed is all together, negative on the outside. This one, what is being cubed is everything in the parentheses. This one would be written -3 times -3 times -3. Now, -3 times -3 is a positive 9. Positive 9 times -3 is -27. Now, they happen to come out right. I meant to write an equals there. They came out the same, but let me show you what could be different. What if this one here were to the 4th power? Let me just make some room. This one equals -27. Okay. What if instead it was -3 to the 4th power? Well, that would be -3 times -3 times -3 times -3. Well, now we have to know what 27 times 3 is, and I will tell you that's 81. Now, because it's a negative times negative, that makes a positive. This positive times this negative makes it negative. This negative times this negative, my final answer is positive. And let's compare that what we have up here. This again, if we did -3 to the 4th, it's negative, but then it's 3 to the 4th. Three times 3 is 9, times 3 is 27, times 3 is 81. But this time, now I stick the negative in front of it. So the parentheses will make a difference if it's an even numbered exponent. If it's an odd numbered exponent, they will come out the same. They will always be negative. And again, with our homework, we'll be practicing more on that. You'll get a little bit used to that. So here we have a division problem. So let's just take each term. Let's take 4 divided by 2, and let's just not even worry that, oh my gosh, it's got all that stuff after it. What is 4 divided by 2? I heard that. It's 2. Well, now let's just look at this middle part. A to the 7th is being divided by a squared. I'm not dividing the a7 by the b because my rule is the bases have to be the same. So I'm going to divide all the bases that are the same. And when I'm dividing, I subtract the exponents. So it's 2. 4 divided by 2 is 2. I'm going to keep my a, but what's my exponent going to be? 7 minus 2 is 5. And then I'm going to keep my b's. There's my b. But it's 6 minus what? We don't see it, but there's a 1 there. 6 minus 1 is 5. So this equals 2, a to the 5th, b to the 5th. This next one, 4 to the power of 0. Now, a really common mistake is to think it equals 0, but it equals 1. No matter what the base is, anytime you have an exponent, a base being raised to the power of 0, the value is 1. I can say xy to the 0. It's going to be 1. Actually, it's going to be x because it's x times 1. That was a really bad example. Let's take 17 to the power of 0. It equals 1. How about a to the power of 0? It equals 1. How about negative 4,325 to the power of 0? It equals 1. What's the rule here? Anytime a base is raised to the power of 0, it equals 1. And our last rule that we're going to look at, what if a problem looks like this? A fraction that's in parentheses with an exponent on the outside. So the exponent outside of the parentheses is distributed to both the numerator, which remember is the top number of a fraction, and the denominator, which is the lower number. So this example would be 2 cubed over 3 cubed. Because remember, there's like ones. Any number that doesn't have an exponent, there's really like a little 1 there. And remember our rule, when we have an exponent outside of another exponent, we multiply. So it becomes 3 times 1 and 3 times 1. So let's do some practice. What if I have something like 1/2 squared? That will equal 1 squared over 2 squared. And then we could calculate it out. 1 squared is 1. 2 squared is 4. It would equal 1/4. But I'm not worried about answering them all. I just want to practice doing the distribution. So let's take another fraction. 7/8 to the 3rd equals what? 7 cubed over 8 cubed. Well, how about something like this? What if I had 7 over x to the 4th? Well, don't let the x freak you out. All the rules the same. It's going to be 7 to the 4th over x to the 4th. Well, let's see. What if I have 2/3 to the 6th? Well, it's going to be 2 to the 6th over 3 to the 6th. But look at this. I have a negative on the outside. That means I'm going to make it negative. Let's try another one. How about negative 2 over 5, and that's being raised to the power of 3. Well, this negative doesn't do anything, so my answer is going to be negative 2 cubed, 5 cubed. How about if I have something like 1/2 raised to the 5th? Well, 1 to the 5th over 2 to the 5th. what if I have something that's 2 squared over 3 to the 4th, and it's being raised to the power of 2? Well, now I have to remember there's an exponent on an exponent. My rule is to multiply. So this would equal 2 to the 4th, because 2 times 2 is 4. And this would be 3 to the what? 4 times 2, this would be 3 to the 8th. Let's do another one. What if I have 2x squared over y cubed, and I want to raise that to the 4th power? Okay, well, this exponent is going to get distributed to each term. So the 4 needs to go to the 2, so that's going to be 2 to the 4th. It also has to apply to the x. 2 times 4 is 8. So my numerator is 2 to the 4th, x to the 8th. What is my denominator? Y. 4 times 3 is 12. Now, I just went over these kind of quickly, but again, with a little bit of practice, you will be fine. Of course, we'll go over this in class. Please bring your questions if you have them, and be ready to work. And I'm looking forward to seeing you in next class.